Okay, we're ready to go.
Okay. So yeah, I'll walk you through kind of my thinking because it is something that happens to me over and over again. Like someone will come to me and say, like, we have this great data set. We're pretty sure there's all sorts of interesting stuff in here, but we don't know how to get it out, right? And sometimes they're right. There is really interesting stuff in there, and sometimes they're wrong. There's just nothing useful in there. But it's as you as the person who's working with data and who has the skills to really get in there and pull things out. Like it's usually up to you to figure that out and try and convince them one way or the other. So when I was first exploring the cloud at the AGRC, we have a big project there that was called Discover. And Discover is a big Kubernetes cluster. It produces it serves up imagery and produces tons of log data. So I can go that. I guess I'll kind of show you the GCP console in case you haven't seen it yet. This is the Google Cloud Platform console. When you come in here, like this is your homepage. This is where you can go to access any of the services Google Cloud provides. Things like App Engine or just virtual machines, storage, and also BigQuery. So the Discover server, because it's in Kubernetes, it's very easy for it to generate logs and send them to Google's data warehouse solution, which is BigQuery. And I was given access to this project and kind of shown where the logs data is, and told that my office had a need that they needed to prove to the legislature or show that this program was valuable because we're a public entity, we're funded by appropriations requests from the legislature. Every year you have to go back and kind of show like this is what we've done, this is why we deserve the public's tax dollars, this is why this is a good program. And it was about that time they knew they needed some way to really show that the adoption of this Discover program had really taken off, right? They could tell people, oh, we have a lot of users, we get calls all the time, but to be able to say in detail like why was important. So they connected me to this logs data set and just said, see if you can show that from this data. So first thing I'll do is just get access and go and look, what's here. And we can see when you go into BigQuery, there are all these options here, but here is where your data lives. In the resources, this right here is your project, which all GCP resources live in a project. It's where you're kind of build an application, and it's a container for billing, permissions, things like that. There's a project here, and then the next layer are data sets.
Are those the same kind of projects that you would see in the regular console?
Yeah.
Okay.
Mm-hmm. It's just a normal Google Cloud project.
Okay.
And how BigQuery fully qualifies its table names. Like if you worked in another SQL database, it might be the database name, the schema, and the table. Well, BigQuery uses the project as kind of like the database name, the top level container. Then there's data sets, which might be like a schema if you're working in Postgres. And then it goes down to just your normal tables that actually contain the data. So here I've got this logs data set. I can get some information about its schema. See, there are really not that many fields here. And some of them kind of make sense, like a user, a size, times. Then I kind of want to know, like, how big is this data set? Like, is it going to be hard to work with? And I can go in here and see like, whoa, okay, this is a decent sized data set. It's half a gig. There's 1.5 billion records. So I might have to think about working with this data set a little bit. If I just naively hammer it over and over again, that's going to generate a lot of usage.
That's half a terabyte, right?
Yeah.
Okay.
And,
wow.
and in BigQuery, you're charged by how much data you use. You don't have servers that you have to worry about. So you don't go and say like, well, I think I need 8 CPUs, so I'm going to turn that on and just pay for those 8 CPUs, whether or not I'm using them. right now, when I'm not doing anything, I'm not paying for any servers in BigQuery. They're just gone. They're off. Other people are using them. I don't have to worry about them. But then as soon as I go to run a query, Google will provision a whole bunch of servers for me right when I need them. Now, because charging for that would be weird. I'm worrying about like fractions of a second on like 50 CPUs. They just use the amount of data you scan as a proxy for that. So that's really nice. But when you've got a big data set, then you have to think like, okay, how much data am I going to scan? I don't want to just scan it for no reason, because that's going to generate a big bill. So now I kind of know, what I'm dealing with here. There we go. I can go in and actually look at some of the data. Another nice thing about the BigQuery UI is that you can get a little preview here. It doesn't cost you anything. It's just really easy to go look what kind of data is contained in your fields. So you can see here, user, just some sort of username maybe. There's this path, which looks giant and messy. There's a size that's probably like megabytes or bytes. A nice timestamp and a few other fields. So when I initially look at this, I think like, uh-oh, like my boss came and asked me to show that this program was valuable with this data set. I don't have a lot to go off. Like I could show like, oh, hey, a username uses like a lot of data, but that on the surface, that kind of looks like it, because this looks like a mess. But then as I start looking with it at this field, like there's actually a lot of information in there. It's a URL. So just a REST endpoint with a bunch of parameters. Like, okay, like that could be useful. I could pull some interesting information out of there. I've got a layer, these tiles, but I really don't know what it means. So that's the time where I've got to, think about the domain and what does this data mean in the domain, right? So then I can go back and talk to someone like, what is this discover service? What does it do? Sorry, I've got like this little bar there.
Careful which tab you open, Keaton.
I know. So I can go ask a bunch of questions and look at things that use a service, and it turns out this is it. This imagery in the background here that looks like Google Maps, that is Discover. AGRC will purchase aerial imagery to serve up to other state agencies and like federal agencies so that they can use that and don't have to pay for license services like Google Maps, or that they can use this sort of imagery for basically almost anything they want.
Does Google Maps use this?
No.
Oh, okay.
But AGRC used to purchase the same imagery that was in Google Maps. They used to purchase that from Google. That program's been discontinued, but it's the same type of imagery. And just interesting point about the program, like this is necessary because Google Maps imagery, or almost any Maps imagery you use from another service, is licensed. So they'll say like, you can use it for a web application, but you can't store it, you can't do anything with it, you can't transform it. And that sort of stuff is really useful to like science use cases. So AGRC buys this imagery and they serve it up from their big Kubernetes cluster to a bunch of different public entities, right? So now it's a web service, so that's why we have a path URL. That makes sense in the log data now. But I need to know a little bit more about how it works. So you can see here that like as I zoom in and out, there are these little squares coming and going. And also there are different like types of base maps you can use. So this is good information that is, essentially domain information. Now I can go back to my logs and kind of understand like, oh, okay, we've got a layer and it's Utah and topo base map. Well, that's the same names I saw in the web application. There are these tiles that are kind of a rectangle. That's the little squares that come and go as you zoom and look around the map. And that kind of gives me some context on size too. Like the size is just the bytes of that data, of those little image tiles that are being served to everyone. I also was able to learn that the user, for most of this access is public. Anyone can use this as a normal map tile service, and you can just go put it in your web application. But there are certain high resolution layers that only licensed users can access. And these licensed users are ones that are like federal agencies that contribute to the purchase of this high resolution imagery. Some of it's like crazy 3-inch stuff where you can see like, something that's been left on the sidewalk, things like that. So that lets me know like, okay, so these users are ones that care enough about the service that they actually contributed money. So if I've got to go, talk about money and how people value the service, like this user field is probably going to be pretty important. Maybe I can parse out like which of these layers they care about the most, because we buy these layers or spend compute resources to produce them. So, which one is the most valuable? And how much data do they pull? That puts a strain on the system and causes us to scale it up, which of course costs more money. I can get metrics like that and then maybe go back to the decision makers and explain like, this is why it's valuable. But the first challenge I see as I start to work with this is, most of this is pretty easy to pull out, but this is not, right? I can't do a whole lot of SQL on this to make sense of it. But I know that like if I deal with text data and matching text data, like Regex is probably a pretty good tool. So now I need to know like the database I'm in is BigQuery. I need to know like kind of what's available in BigQuery to deal with that. I can just go look at the documentation. The standard BigQuery has 2 types of SQL, the old stuff, which of course they call legacy, and standard SQL. Always use standard SQL if you can now. I can find a docs page that has a bunch of different functions. There are all sorts of, compute functions that you can just run in a BigQuery SQL statement. And there are a whole bunch of them, which is great. It means my queries can be very, flexible. I can transform a big messy field like that path in a lot of different ways. Oh, and here's all the nice regex stuff you can pull out text with. You can read all about how it works here, have a few examples, and a little bit of sample code to get you started. This takes a lot of exploration. I have to come in and get these functions, try things out here. You can see in my query history, I've got a whole bunch of different queries that I try as I iterate and try to figure out what works and what doesn't. But we also saw that table was pretty big. I don't want to hit it any more than I have to. Luckily for me, this table, it's streamed in and partitioned. So I can pick the partition field and filter on that with a where clause, and I won't scan the whole data set. So I can experiment on a small data set. If it wasn't partitioned, you could always query out maybe 1,000 rows. And when you do that, you probably want to take a random sample. Don't just query like the top 1,000 rows. So you get something that's representative, and then just work on that small little data set for a while until you figure out what your query needs to be. Then move it to the larger one. It's simple, a little obvious, but it really helps out when you're dealing with these large data sets. So after all my work, I was able to develop a query that kind of pulled out the essential information. And as soon as I was done with it, I saved it. Another nice feature about BigQuery is that you can save queries right here in the UI. Then other users in your projects, if you're working with other people, can come in here and access these project queries and expand on your work or use something that's authoritative that you created. So you can see here in this one, fairly decent sized query, a lot of inner queries. The real interesting stuff that's happening is parsing out that path field, that big URL. I do a bit of parsing to pull out these different service types, and then the layer types with some crazy regex. I can run this
Did you
query.
use a tool? Did you use a regex tool for that, or did you? I mean,
Oh yeah,
or what did you use? Just regexpert or whatever?
it's all just stored in my memory, and that's my
I
second
mean,
language is regex.
you're kind of an android, so I don't, I'm not that surprised, but
That's true.
okay.
So regex 101 is my favorite, I'd say.
Oh yeah, okay.
This is great. You can put any sort of string here and then try to match it. You know, really helpful.
We only briefly mentioned regex in class, so those of you who aren't familiar with it, it's a way to search through patterns of text and different characters to find what you're looking for, basically, right, Keaton?
Yep. Like maybe a quick example here, and I'll probably like brag that I'm so good at regex, and then I'll totally mess this up.
It's
Okay.
like don't do anything live.
I know. So there, so the simple thing here, like we got a bunch of letters, and let's say I want to find the number in this string, and /D. You can see down here, there's a whole bunch of different like special characters you can use to find certain classes of stuff in your string. /D turns out to be any digit. So I searched for the pattern of /D in this group of letter and number, and I found the one because there is the digit. Let's say I do like.
Are you seeing the chat, Keaton?
No, I am not.
Okay. Eric says regex is a good tool to make sure you cover edge cases. Thanks, Eric.
For sure. Yeah, and so then there's all sorts of quantifiers where you can search for maybe like one or more. I think this is the right one. Yeah, so there, found two. Just want to find one. It actually shows that I have two matches. Yeah, regex is great. It does take some experimentation to try to match what you want, but it's a super useful tool to have really in any SQL database. So I use that regex and parse out part of that big URL that I think will be useful. Now for the fun stuff, I can actually run this query. You can see BigQuery has a handy feature. I said you're charged for the amount of data you scan. You can write a query, even a crazy big query, and BigQuery will estimate how much data you're going to use when you run that.
We'll be charging this onto your tuition, so.
Yep.
Just kidding.
You didn't know that your class fee was going to be coming to me, but there you go. If this is not cached, we'll see how long it takes to run over this 200 gigabytes. What was that? 1.5, almost 1.5 billion records.
Yeah. 400 gig, right?
Yeah. Oh yeah, 400 gigs. This would kill, if you had a little SQL database on your machine, especially, or even in the cloud, like this would just wreck it. But if we're lucky, it'll take just over 20 seconds.
So Google right now is actually automatically spinning up the resources necessary to run that in real time, right?
Yep. Yeah, I probably just got access to like, I don't know, 10, 16 servers to shuffle all that data around and run this query. And you can see there it took, 22.2 seconds. And if you spent much time in SQL Server databases that you would provision kind of the normal way, they're just sitting on one, server somewhere. This is Lightspeed compared to that. Like that, you would run out of memory. It would take hours. It would just wreck it probably.
Who's Calvin? Jeez.
Calvin?
He's Calvin. He's the user on all these, or a lot of them.
Oh yeah, Calvin. Oh yeah, I know Calvin.
Oh, you do? Okay.
Turns out Calvin is actually the main developer on this system. So.
Oh, okay. Well, that makes sense.
Yep. But you can see here, like this table I created from that query, like it has fewer fields, but now I have exactly the information that I want.
Sorry, Keaton. Ben, did you want to say something?
Oh yeah, I was just going to type it in the chat, but I was wondering if from this page, if it's possible to see stats on like how many servers, how much RAM it took to actually process that.
You can definitely see some of that, which is here in the execution details. So here, I mean, some of this is pretty specific to BigQuery. You kind of have to know what it means. But you can see like the amount of bytes shuffled, that's like the data moving from one machine to another to complete an aggregation. You can see here like the first input was everything, that 1.5 billion rows, right? And then it moves to the next stage, and you see there's a lot less. There's only 1.9 million. Once you kind of start to learn how BigQuery works, you can use this to make your query really efficient. Like if I wrote a query that didn't have all those inner selects to kind of filter stuff out, I might pass this 1.5 billion rows to each stage here. That means that each query after the first will have to go through all that data again. And all that data will have to be moved to other machines, which is really efficient. But you can see here like that my query filtered it down pretty fast.
It's almost like it's mapping it and reducing it somehow.
It is exactly like that. Like, deep down in the history of this thing is just MapReduce, like pretty much everything at Google. It is like a couple iterations on that, something Google calls Dremel in the background. But yeah, fundamentally, somewhere in there, there's MapReduce. So yeah, you can see here like the wait time, that's important. It's just how much your node is like waiting before it like maybe gets all its data before it can start working. There's not really any information about how many servers you get here, but this is the essential information if you're having performance problems. Like you need to start to understand how this works and hit these targets, where they need to be, from your query to this. So it's a great tool for debugging performance. My longest one was this giant amount of compute. I'm almost certain that is this Regex. There's a whole lot of Regex happening. Regex is compute intensive. That was probably the Regex in that stage, got out of the way, and everything else was pretty fast. You can see important things here, which is not easy to see because all mine's it doesn't have a lot of outliers. Like if you have a big outlier, there'll be this like dark bar, and then there'll be another bar that shows like your average node maybe took 3 seconds, but there's this one node that took like 3 minutes. And so then your data is skewed. You probably won't hit that unless you're doing something pretty crazy, but it's just, if you have performance issues, you can go read all about it, and it definitely helps. So yeah. Once I've got my results, like, and now I can kind of see, all right, maybe this is the core information that I could actually answer some questions with. I've got that crazy, like billions of bytes down to something reasonable, megabytes or millibytes here.
And this is your sample size that you were talking about, right? Oh,
no, I ran that on the full thing.
Oh, okay.
But yeah, so if I was running it on a smaller sample, then I just produce, I would use that smaller sample, maybe 1,000 rows, to get this output table that I thought was good. And then I'd finally go run that query on the full set of data. Just another important point, like the minimum bytes build for BigQuery is 10 megabytes, because that's still like a fraction of a cent. They've got to cut off the penny somewhere. But if you're taking a sample, that's kind of good to know, because you can figure out, like based on your field type, how much data that is, or basically like on how much you're scanning, how much data that is. And might as well make your sample 10 megabytes if you can, because you're going to be charged for 10 megabytes every time anyways.
So were you charged for 192 gigabytes? Was that?
I was. Yep. That's like a whopping, it's $5 per terabyte, so $5 per 1,000. So we got like 2% of that. I don't know, not very much.
Like 25 cents, right?
Yeah, yep. And 25 cents versus waiting 8 hours and dealing with like three failures and starting that 8-hour process over again, I'll pay the 25 cents.
Yeah, but you're not a starving student.
No, that's true. Well, lucky for you, I don't know if you have like the education credits or something weird like that. I know Google has a program like that, but
I tried. But then Greg Goebel left. He was the one that was working on it. But we have Microsoft Imagine, so if you
okay.
want, you can do stuff in Azure, I think, for free too.
Oh, cool. And Google, like if you go and get a free trial, you will have to put in a credit card, but they'll give you $300 to spend for a year. And if you don't go in and explicitly say like I want this project to be a real project now, like as soon as you run out of that $3, it'll just stop. Like it won't charge you anymore, and it'll just be done. So you can get that $300 and just go nuts for a year, basically. It's great for learning. I know they
Yeah.
have
So
some.
sorry. I was just gonna say. So you guys are doing that. When you do your term project, they're just using the free because there's no way you're gonna rack up $300 on your term project. I mean, I hope not.
I'll be impressed if you do. But yeah, so now I've got my data set, and I think I can answer some questions for it. I've got the actual day that these use happen. I've got all the use per day, per user, per layer, which remember layer was just like the different map type here, and per service. That doesn't matter as much. You know, all that aggregated. So now I can see, you know, Calvin per day, how many requests he's making. So how many times he's just hitting the server and how much actual data he's pulling. That was something else I discovered, you know, in my domain exploration, that there are kind of two usage patterns of a server. Like they're small, you know, lightweight tiles like this, you know, maybe this, let's see, I'll find one eventually. I don't know, one of these, which is mostly just like, it's just lines. It doesn't consume a lot of data, but people might, you know, applications might zoom around it really fast, and so it uses a lot of requests. That kind of puts one type of load on the server. There's another usage pattern where people maybe pull those big image things, but they'll like pull it for the whole state at once. So it doesn't, it's just like a big burst at one time, but it pulls a lot of data. And that's kind of another sort of usage pattern in the system that matters. So I pulled out those two independently. So this is cool. Like I could come in here and tell someone like, oh yeah, we have, you know, run some more SQL and say we have like, oh, we have 10 users who use like 90% of our data or something like that. Or, you know,
And they all work for us.
yeah. And or like the Salt Lake City layer is the most popular, you know, that's great for me. Cause like Adam said, I'm an Android, so I love numbers and SQL, but for everybody else, it would be nice to kind of see a visual of this. So Google has another great tool. Like once you parse out the information you need to, you know, answer questions, then you can use a BI tool called Data Studio. This particular tool, Google provides it as part of a lot of G Suite accounts. I'm not sure if it's in all of them, like the most basic or free one, but it might be. And it connects to a lot of different data sources, but BigQuery is definitely one of them because it's all Google. So what I did then was take my data set of useful information and connected it to BigQuery. I'll just caveat this, like I said, like I'm a back-end person. I like pushing data around. The visuals here aren't exceptional. I made them, so just bear with me. But
I mean, I wouldn't use a pie chart, but you know,
that's what everyone tells me. Like we don't like pie charts.
a
Why
donut
not?
chart is much better because you can put more information in the middle of a donut chart to explain stuff.
Okay.
You know,
That's for you fully functioning humans. I'll believe you. Stick with my numbers. So now I kind of see here, like I've got a nice time series here. I've got the request per day, that usage pattern where it gets hit for a bunch of little data very often, and all this megabytes per day where you get these big spikes where someone comes and downloads a giant data set.
yeah, somebody wanted something around Christmas. It looks like Christmas 2015.
They do, and this one's new. I haven't explored this one. What was actually cool is when we made this, like this happened, And this wrecked our server. And we didn't really know back then why. Like we tried to kind of parse out the logs. It wasn't clear.
Was it on GCP at the time?
Yeah.
Okay.
But it didn't have as, like, we added more auto scaling functionality because of this. But, you know, we were able to come in here and really see who did this. So maybe I'll show you real quick. This will probably take a bunch of time and be a bunch of awkward silence, but
we want to know, Keaton.
January 25th, I know, right?
Hey, I bet you could key in the year.
You could. So it was 2015, I think.
Yeah. January 20, did you say 25th?
I think so. I'll just do it over that range and kind of see what we get, or I'll do it closer maybe. That's great.
That was anticlimactic.
It really was. I was hoping.
Wait, wasn't it December? Wasn't it December though?
I think it was January, but I picked the wrong year.
Oh, okay. Oh yeah, you have 2016 on the left there.
We'll try one more time and see what happens. Nothing, because it's still wrong. That's fine.
You're messing with the space-time continuum now.
I knew I shouldn't have done this, but now that I started, I feel like I have to finish it. I don't even know if I got the right date there. Moral of the story is, like, what I was able to do is take this this distribution, this pie chart, and see what it normally was. And then I zoomed in right to that time and saw, like, oh, all of a sudden this one weird user used everything. So then I knew it was that user.
And you found, I'm going to guess that this is pretty much how you found out that somebody was maliciously using our Google account for map data, like around, like, was it last year around Christmas?
Yep. It was a different system, a different visualization, but yeah, very similar process where someone, you know, key was compromised and someone was just hammering the heck out of it. Luckily, we found that, you know, early enough and was kind of able to shut that down, prove that it wasn't used in an election system and all that good stuff. But, you know, that's a good point. Like, having visibility into your data, like, you don't know what's there, and you probably, being able to answer questions from it can be very important and even mission critical sometimes. Like, if we weren't able to see that Google Maps thing, we could have racked up a huge bill. But if you remember, like, what they originally came to me with was like, oh, we've got to go do a funding request. And we got to prove that our system is useful to the legislature, right? And so we can kind of see here, like, oh, now we can show, like, oh, there's all these users. Look, the trend line's going up. Everyone loves it when it goes up. Now we go say to the legislature, like, the usage is growing. Look, we have all these users. And oh, how about this? The Utah legislature itself is in the top 10 users of our system, right? And that's who we have to go ask for money. So that leads me to think, like, okay, well, what does the Utah legislature like to see? Maybe when we go do a presentation, we'll pull up that layer, right? And so I made another set of graphs here where I can kind of see data usage by user. So we can see here.
I'm a big fan of the 100% bar graphs or column graphs. By the way, good work on that.
These are actually cool. This was my masterwork when it comes to data viz.
Oh, okay.
Now, they can see they like the hybrid base map. Okay, that's good to know. Gives us some good context. But, you know, being able to say that, like, okay, go from, you know, the question, like, we need to kind of show to this group, like, why our system is valuable. Here's a bunch of logs that kind of look like junk. You parse it out, you think about it, you learn about the domain. and take it to the point where you can go and say like, oh, you remember this group you're going to ask? Like, now you can go and show them like you are one of the top 10 users of the system. Like, not only legislature should you fund this because your constituents care about it. You know, Carbon County cares about it. Guy from Carbon County.
That one dude.
Yeah, you support it. You use it to support your core mission in the legislature as well. So yeah, you should probably fund it. You know, that's in the data field. There's a technical term for that called SFD. That's a slam freaking dunk. Right? you can't get better than that.
I've never heard that. That's good. I like that.
It is. It's a very technical term. I learned it in the CS program.
Okay.
So yeah, and that's just kind of my process from start to finish. You know, you can see there is a lot of back and forth. It can be messy at times, but you just have to have that curiosity. You know, if you get the hint that there's something in there and you've kind of been given a business need that's pretty broad like that, you've got to go explore. There's no other way. And if you're the one with the tools to explore, like, you've got to do it.
You're compelled to do it.
Pretty much, yep.
Yeah.
Yeah, all this is less interesting to people that don't know about the system, but
Cool. Any questions for Keaton? He'll answer personal questions, relationship issues, anything you want.
totally.
Does Data Studio work with outside data, or does it have to come through GCP?
No, it can work with many different data sources.
And the reverse is true too, right? You could connect Domo to this, for example.
Domo, like to GCP data sources like BigQuery?
Yeah.
Oh, yeah.
Because I know that you has some sort of partnership with Domo too, where I think you guys might get free Domo or something. I'm not sure.
Okay. Yeah, here you can kind of see all the data sources it works with. Like, they, of course, list all the Google ones right at the top, but you can see you can connect to any sort of MySQL or Postgres database. Also other random weird like XML feeds, things like that. You can
Unknown connector. I like that one.
Yeah.
That means you have to pretty much program your own in there, right?
There you go. Yep. You can definitely do that.
Build your own. Yep.
And it can even connect to a Google Sheet. I mean, you can't do 1.5 billion records in a Google Sheet, but you know, it's handy.
You can't even do what Excel can do in a Google Sheet.
Yeah, that's probably true.
Cool. Anything else for Keaton? Oh, we got a chat. No, thank you. Okay, Eric, thanks. Got your chat. Yeah, so I'll with Keaton's gracious permission, Eric says, thank you for your time, Keaton.
You're welcome.
With your gracious permission, Keaton, if you don't mind, I will post this on an unlisted YouTube and then post the link on our canvas, if that's okay.
Yeah, sounds great.
Okay. Adam also says thank you. Okay, thanks, Keaton.
All right.